Well, hello friends. Today we are going to make the wheel on the mouse work. So currently we don't do anything if I wheel the mouse. And I guess at the very least it would be cool if it would generate some kind of input event. And then of course we should be able to do something like scrolling the thing here up and down. Text editor, right? Yeah, words. So let's just get right into that. So I found this web page here that sort of describes how the thing works. Basically, to enable the mouse, you want to do this little sequence here where you send a few commands, and specifically you set the sample rate to 3 different values, and then you ask the device what's your ID, and then if you did this sequence, then it will tell you a different ID, and that ID means that from now on I am reporting wheel events. That's how I understand it. So let's just go in the mouse initialization code here, and right after we're done with the normal setup, we can do this little sequence. So let's see, set sample rate is command F3. Okay, so actually let's make define for that, like ps2 mouse set sample rate F3, and I think that's, is that all we need? Oh, and we need this one as well, F2, get device ID. Get device ID F2. Okay, and then we have the ACK up here, although it's a bit weirdly named, but yeah. Okay, and then let's use these. So let's say that first thing I'm going to do is send ps2 mouse get device ID, and then I guess we can we just want to get the ACK. So like I guess we can say read ACK or expect ACK. We can make a helper for this, because otherwise we're just going to type this thing over and over again. So we'll say byte data mouse read. Search the data is IO, what was it called? Yeah, this number. Okay. And expect ACK. Okay, and then we can actually use this like here and here. Okay. So get device ID. It's gonna tell us, I guess it's gonna tell us ACK, and then it's gonna yeah, followed by its device ID. So it's called device ID is mouse read, and then if device ID is already what's it called, IntelliMouse extensions. Yeah, so if a Microsoft IntelliMouse is attached, it will respond with the ID 03. So I guess we call that IntelliMouse ID. That too. Okay. So if it gives us this ID, then we don't have to do anything because it's already in the right mode. But if it doesn't, then we got to do this thing here. So send magical wheel initiation sequence. Okay. Mouse right. PS2 mouse. Set sample rate, and I guess mouse right 200. Right, yeah, so we just gotta send these, and then I guess we'll get an ACK after that. 200, 180, okay. And then we can refetch the device ID. Oh shit, first we gotta, that's right, get device ID, okay. And then we expect the ACK. Okay, and then here, now if device ID is PS2 and telemouse ID, then we can say has wheel true. Okay, and let's add a member for that. Okay, so let's see if this even works. So let's just say has wheel is what exactly? Well, I didn't see what happened. Has wheel 0. So that didn't work out. Okay. F3. Okay. So how did we send those F3 things? It will respond with acknowledge and then reads one more byte from the host. So I guess I did that slightly wrong, so we just gotta expect ACK after we send this. And then let's hang after we print this, just so we can easily see how it went. Okay, so now we have the wheel. Good. Okay, or actually, let's have a little print message here. So let's say PS2 mouse device. Put this here. Here like that. Mouse wheel detected. Enabled. And otherwise, we can print out that no mouse wheel. Okay, and don't hang. That's pretty cool. All right. Now what's going to happen is, wait, until mouse extensions. So after we do this, then from now on we're going to get this packet format instead of the other one. So the other one is basically identical to this, except there's no 4th byte with the Z movement. So normally you only get X and Y movement deltas, and once you enable the wheel, then you also get the Z axis, which is the wheel axis. And it says here that Z movement is a 2's complement number representing the scrolling wheel movement, blah, blah, blah. So it's just a delta since last report, and the valid values are in this range. So we only need to care about the bottom 4 bits, and it's a signed integer. Signed 4-bit integer. Okay, so what we're going to want to do is, first of all, we're going to need to cache 4 bytes in the interrupt handler. And when we put those somewhere, we're eventually going to want to create these mouse packet thingies. So this is going to have a DZ value. Oh, missing initializer here. So yeah, it's going to have a delta Z as well. Okay. So now let's go in the IRQ handler for this PS2 mouse. And here, I guess we can, so this is like, which byte are you receiving? Because you get one interrupt for every, wait, is it that way that you get one for every packet? Or, no. You get an interrupt and then you read packets until you have a whole packet. Right, and then what we do is that we have this little state thing here that just tracks which array index in the packet buffer that we are to write to next. So normally, or previously, we would always consider the data packet complete if we got to index 2, so the third index. But now we're going to want to go one step further, so I guess we'll say, like, if we have a wheel, then we just advance one more and break. Otherwise, or actually no need for the else branch since we're breaking. Otherwise, we can commit packet, and we'll make a little thing for that. So we'll say like commit packet is this hunk of code basically. And then if we actually get to number 3, then we can assert that we have a wheel, because otherwise we shouldn't be there. And then we commit at that point. And committing will reset to state 0 again. Okay. So let's look in the parse data packet. I guess now we have in Z, it's mdata 3. If we have a wheel. And what is mdata exactly? It's a byte, okay? So then it would be in, I guess that was the bottom 4 bits. And wait. Should we do a reinterpret cast int? Actually, we don't need to, because we don't have to mask them off. It's just that they're not relevant. But why am I braining out on this? What the hell is the way you do this? I just want to sign extend it. Do I have something for sign extend? Okay, so let's just say reinterpret cast char. Okay. Maybe this. I'm a little bit rusty on the fucking cast semantics. Whatever, we'll notice if it's not right. Okay, and then down here, when we create the mouse packet, we're going to say vz is z. And I guess we can print out the packet that we have here. So let's say like ps2 mouse packet dx dy dz buttons. Okay, and then that will be packet dx, packet dy, packet dz, and packet buttons. Okay, let's see how this looks. So we got all these things happening here, as you can see, and then if I scroll up, I get some -1s in the z delta. If I scroll down, I get some 1s. Scroll really hard. Can I even get more than that? I don't know if it's possible. Maybe it doesn't happen with QEMU or something, or maybe I'm not scrolling hard enough. But anyway, that is certainly working. So now we are going to want to, probably the first thing is that we're going to have to rebuild everything because the mouse packet just grew. And everyone expects mouse packet to be a predictable size. Excuse me. Okay, so let's go in the Windows Server now, where we actually retrieve these mouse events. So in Windows Server, we would end up here in the Windows Server screen class in the onReceived mouse data. It gets called every time there's some new data available from the PS2 mouse device. And what we do is, oh, actually, we're going to have to go to the call site of this guy and do a little bit of tweaking here. Packet tz. So we have to actually extract the z delta, because what this thing does is that it actually coalesces all the available mouse packets into a single delta, if possible. And that is so that we just don't get stuck with a huge queue of mouse events, basically. There we go. Okay. We gotta change the signature of this guy. Okay, and now we are here. So now we're in the Windows Server screen on received mouse data. And I guess, so the way that this thing works is that it will move the mouse cursor information in the Windows Server screen, and then it will check if any of the buttons change state, and if so, it will generate either a mouse down or a mouse up event for that button. And then also if the cursor location has changed, then it will generate a mouse move event. So I guess we're going to want to also generate a wheel event if there's a z delta. So I guess a wheel event is just going to be like an x and y coordinate and the delta. I think that's what should be in there. So, but let's just print it out here so that we know that we have everything that we need. So let's say if dz this screen wheel delta. Okay, and let's go and remove that debug spam that we had in this thing, in the mouse driver. Okay. I'm wheeling and nothing is happening. Okay, well that's not good. So let's see. So we were putting all the info in the packet. Let's go then in the Windows Server event loop. Let's see that dz is this. Okay, I mean, let's just print it out then here, whatever, see what it says. I am not afraid to printf debug, as you can see. Someone asked me today what kind of debugger I use, and as you can see, I like to use the printf debugger. Maybe I just forgot to compile a bunch of shit now. Is that what I was messing up? Yeah, I just didn't compile anything. See, that's how smart I am. Okay. So now that we do compile, we get the wheel delta in the WS screen. Cool. Okay. Then we are going to want to define a new type of event, just like WS mouse event, but slightly different. And I'm wondering if this should inherit from mouse event or something, but maybe it should. It's gonna have all the other state. Let's just call it a mouse event, and maybe I have to rethink that later on, but say wheel delta. Okay, just add this little member guy. It's definitely an int. Wheel delta, let's return delta. Okay, I think that's cool, but we are gonna need to define a new type for it, at least. Because it's gonna be mouse wheel. Now we rebuild everything, because this changes stuff. Okay, and I guess we can sort of copy paste this code here. That didn't even build, but mouse event, mouse wheel. Oh yeah, and then we have to actually. So let's have a default value here, 0. And then these other events don't need to worry about that, but we will. So what was it? DZ, right? Okay. Now we are posting that message. So where is this going to end up? Is mouse event. We gotta tweak this guy too, actually. Or the type is mouse wheel. Because I feel like is mouse event is used in 2 places. Yeah, so it's just used to determine if we should do some special handling for this event. So okay. So now we're in the Windows Server window, and we have received a mouse event for this window. And what we're going to do is we're going to pass that event on to the client. So for that, we need to convert it to a client readable type, because currently it's like in this internal Windows Server type. So we got to convert it to a WS API server message type mouse wheel, which doesn't exist yet. So we got to add it. Okay. And this is the server message, and for mouse, the mouse part of the server message, we need to add real delta here. Okay. And we will populate that thing here, event.real delta. Okay. So let's see, there was one more place we were using the is mouse event. So where the hell was that? And a window manager. Oops. Process mouse event. So probably we don't need to do anything in particular in the Windows Server right now for the wheel. Maybe there's something we could do in the future, have it actually do something, I don't know, like change the opacity of the window or something. Sounds kind of stupid, so, but right now we're not going to do anything. But we have to deal with this in the client code now. So now we're in the libGUI event loop on the client side, and we have just received a mouse event. So we are going to convert it to the local type. It's a mouse wheel, then we will generate a g-event mouse wheel. And the gmouse event. Yeah, I guess we'll just include the mouse wheel delta in this thing. And the gmouse event, yeah, because I kept thinking, like, should I have a gwheel event? But I think gmouse event is fine, and then because it's going to end up in a different handler anyway. So what really is important is that we have all of the coordinates and stuff, because to be able to handle a wheel event, we really need the coordinates and the wheel delta, not just the wheel delta. Okay, so let's just make sure that every mouse event has a wheel delta, and delta const return and wheel delta. Okay. And oh, I need to add the G event type for this. I will just go here, mouse wheel, and likewise here there's is mouse event, so I'll have to add that. And where is that used? Actually, nowhere. Oh. Okay, then let's remove it. And it's really used nowhere. Okay, well, fine. Oh, I see, because we just do an explicit check here. Well, then I guess I will just tack this on here instead. Mouse wheel. Okay. So now we're in G window event, and hopefully all of the plumbing that we just wrote has delivered a G mouse event to us here. And now what's going to happen next is that the G window will look at his widget tree and determine which of the widgets are you currently over. So like which widget should receive the mouse event. And there are a few things for like this automatic tracking that happens, like if you click on a button and then you drag away from the button while holding the mouse button down, then the button widget will keep getting the mouse events, so that there's a guarantee that you always get mouse up and whatever. Like this is what this is about. But down here is the important part. This is where we oh, this code looks kind of stupid. Checking if there's main widget twice there. So let's just do this. Okay. Okay, so we hit test to find out who did we hit, and then we create a local event that's the local position inside that widget, and then we send it to the widget. So I think we don't need to do anything here actually, because we will just pass it forward to the widget event function, which for mouse wheel needs to do something. So that would be, I guess, return wheel event. And then we will just define that. Should we call it mouse wheel event? I mean, it is consistent with the others, but wheel event sounds nice, but this also sounds nice. I'm going to call it mouse wheel event. Okay, so mouse wheel event. Okay, that's a lot of editing and no compiling. So where do we even test this? I guess in the text editor would be kind of easy. So let's add a mouse wheel event over right here in the G text editor widget. No, it's not G wheel event. And there's still something that I didn't take care of. I gotta look that up. But yeah, so I added this, and then what was the problem in G window? 178. The problem is that I am not passing in the wheel delta. Mouse event wheel delta. Right. I'm sorry. I will pass it in everywhere. I will be a good boy. I'm sorry. Okay. Right, so let's go in the text editor instead. And now we have a new event. It's called mouse wheel event. And oh, how should this work? I guess it should just scroll up and down. So it's a scrollable widget. So actually, that should probably be in the scrollable widget. Now that I think about it. Oh shit! Somebody's joining IRC. I'm just gonna turn off notifications here so it doesn't spam the video. Okay. Sorry, I'll get to you later. Wheel. Let's go in the G-scrollable widget instead. Okay. And here we can add this guy. And we have some event here. Okay, so G-scrollable widget, mouse wheel event. Okay. Shush. Let's see. So the scrollable widget, let me remind myself, it's internally 2 scroll bars and a corner widget, right? So I guess when we wheel, then vertical scroll bar. Can we even do this? Yeah, so we have this helper. We'll call something like set value vertical scroll bar value plus event wheel delta. Wouldn't it be cool if that just worked? Let's try it. Maybe we can also give ourselves a text editor on startup by just tweaking the kernel a little bit here. Okay. Jeez, this build is getting longer and longer. We should probably start thinking about doing something about the build time. Wonder what though. Guess I should figure out what's actually taking the time. Oh wow, almost a whole minute. Okay, now we have a text editor, and if I scroll, then nothing happens. Oops. Well, what was I expecting? I was expecting a little bit more, I guess. So let's see where we go wrong, because I didn't put debug statements anywhere. Let's say in the G event loop that we verify that we got the wheel. So I guess we can do this here, mouse event. And mouse wheel delta. Let's just verify this thing. So let's say the GUI and XE app text editor clean. And run. Okay, I'm not getting any mouse events for the wheel. So Why not? Because here I don't check that for the wheel enum. Mouse wheel, okay. Oh, look at that, and it scrolls. Oh, it actually scrolls, and it's so slow, but it does scroll. Cool. See, oh, and we even have some 2s sometimes, but we're gonna need to scroll a little bit more than that per thing. So let's see, vertical scroll bar. How about we say the wheel delta times 5? Okay, that's pretty good, but I'm gonna go with an even 10 then. See if I can make it feel just right. Probably this should be something derived from some other value somewhere, but it actually does work. That's so freaking neat. Alright. So let's see if we need to clean this up a bit. I guess we just need to remove that debug printf that we enabled there. Okay. And did I have anything else? There's no spam about it. Okay, but it's clearly it's not. This thing is not big enough, so I'm gonna say 20. Fix me. The wheel delta multiplier should probably come from somewhere. Because I don't know where to get it from. I'll figure it out somehow, but constant here is probably not the right approach. Okay, now this is starting to feel a bit better. Yep. Very cool. Okay, so patch review. We did a lot of stuff, I guess, but it's not that complicated. So let's look at the kernel changes first. Yes, they're here. Okay, so for starters, we added these defines here for the PS2 mouse commands and for the ID that we get if it's an IntelliMouse. Then in the IRQ handler, we took this thing that we do when we have a whole packet and we made a little like separate function helper for it so that we can call it from either from the 3rd or the 4th byte down here, depending on whether or not we have a mouse wheel or not. Okay, and then when we parse the data packet, then if we have a wheel, then we will interpret the 4th byte as a signed character and include that as the packet's z delta. Let's do that. We don't need that. There, okay. And then in the PS2 mouse device initialize code, so we added the expect ACK thingy so that we don't have to explicitly read and then check that we get an ACK back. Let me just use that up here. Okay, so then after the mouse is set up normally, then we do send a get device ID and expect it to return an ACK. And then we retrieve the device ID. And if it's not the IntelliMouse ID, then we do this magical sequence where we set the sampler rate to 200, then 100, then 80. And then we ask for the device ID again and save it. And then if it is IntelliMouse ID now, then we say, okay, so we have a wheel. Cool. And then we consider the wheel enabled from that point. And otherwise we say no mouse wheel detected. Okay, and then this was the expect ACK function here. Just read and verify that it's an ACK. There's a declaration for that, and making the mdata buffer 1 byte wider, and adding the bool for has wheel. Okay, and then mouse packet gains a member as well, and then here was just me making it easy for myself to get the text editor, so let's get rid of that change. Let's verify that it works if it still works if I don't have a wheel. So if I don't set this thing, or no, hold on, I don't want to enable this mode at all. So if I don't enable this mode, will things still work? Text editor. Oh, I need to open a file. How about the kernel map? And wheel, nothing happens. Yeah, but it still worked. So that's good. Okay, so let's say git add. Am I adding a bunch of shit that I don't want? Yes, I am. Madman diff. I wonder what's in that one. And these are the changes I wanted in the kernel, right? So let's start with committing that. So kernel add support for PS2 mouse wheel if detected. Okay, and then let's do the rest. So okay, so in the G event we have the mouse wheel type. We get rid of is mouse event because no one is using it. And then G mouse event gets a wheel delta that will be a member of that thing. And then in the G event loop, when we handle a mouse event, then now we'll also print out the wheel delta if the debugging is enabled. And for mouse wheel, we will convert it from the server type to the G event local type. And we post an event, we always include the wheel delta from the Windows server. Okay. And here in G event loop, process on process bundles, we will dispatch mouse wheel to handle mouse event. Cool. All right, and here in G scrollable widget, when we get a wheel event, mouse wheel event, then we will just move the vertical scroll bar up and down based on the wheel delta. That's pretty neat. Very cool. And here's the declaration for that, mouse wheel event virtual. And then in GWidget, when we receive a mouse wheel event in GWidget event, then we call the mouse wheel event virtual, and the default one here is just empty. And here is the base declaration for that. Okay, shit, some white code here. Okay, and then in GWindow event, we also consider mouse wheel event to be a mouse event. And we have to include the wheel delta whenever we construct a mouse event. So we're adding that here and here. And then here I realized that that this was doing double checking here for main widget. So I was just removing this extra nested branch. But other than that, I didn't change anything here, other than passing the wheel delta. Okay. Then in the Windows Server API types, then we are adding the wheel enum to the type enum, and every mouse event will now also include the wheel delta. And in the Windows Server now, the Windows Server event gains a wheel type, and we consider the mouse wheel to be its mouse event, and the WS mouse event gains a wheel delta, which is defaults to 0. Blah, 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 blah. Okay, fine. Okay, and then let's look here in WS event loop. So this is where we drain all the mouse events from the PS2 mouse device file descriptor. So now we accumulate the Z delta as well, and include that when we call onReceive mouse data. And if there is any change in X, Y, or Z, then we will call onReceive mouse data. So that's cool. And then here in WS screen onReceive mouse data, we also get the Z delta now. And if we have one, if it's non-zero, then we will construct a wheel event, and it has the cursor location and all the buttons and stuff, and the wheel delta. And then we just post that to the Window Manager. Which, of course, it doesn't say here, but the Window Manager will then look at the window stack to figure out, like, based on the cursor location, which window should get this wheel event. Okay, and then we're just adding the declaration for on-received mouse data, and then here in the WS window, we convert from the internal Windows Server type to the server message type. And finally, when we send the event, we send it here to the client, then we also now include the event wheel delta. I think nothing here seemed wrong, everything seemed good, so let's commit. Windows Server plus libgui. Handle wheel deltas, mouse wheel deltas. Gives to mouse stream. Nice mouse event stream. The wheel events will end up on G widget. Mouse wheel event inside, which also implements basic wheel scroll widget. Yeah, this mechanism. Smiley face. Cool. Okay, let's push that. And let's see it one more time, because it's pretty cool. Maybe we can see it in some other class, if we're lucky. Let's go in bin. No, that didn't work. Do I need to rebuild it? I feel like it should work, but probably I'm forgetting something. Yeah, well, I'm definitely forgetting something here. It's probably forgetting that I disabled wheel events in the kernel. Yep, look, it scrolls. The item view scrolls. The table view scrolls. Very, very cool. All right. I think I'm gonna be pretty happy with that for today's video. So I'm gonna say the usual, that if you made it this far, then I thank you for watching and thank you for coming back. And I hope you saw something interesting here today, and I will see you next time.